Aloha class, let's get this done, okay, right? We have to finish section 4.8. That video wasn't as long as I thought, so let's see if we can get this done in under 20, so we can get this done in one little lesson for you guys, okay? But now what we're going to do is we're dividing these guys. And when we divide these guys, it takes a whole nother level, okay? Because we have a saying in math, and that is you're never allowed to have an I in the bottom. So how the heck do I get rid of an I in the bottom? Well, this is how you get rid of an I on the bottom. Now, if I have just one term in my denominator, the easiest way to get rid of that I on the bottom is you multiply the top by an I and the bottom by an I. Okay, and if I do that, and the reason why you're allowed to do that, class, is what's I divided by I? It's just ichi. So believe it or not, anything in math, you're allowed to change the way it looks. And that's all we're doing here is we're going to change the way it looks because the SAT is telling me I can't have an I in the bottom. Can't have a complex number in the bottom. So when I multiply the bottom by an I also have to multiply the top by an I because then I'm really just multiplying the entire thing by an ichi. Okay, by an ichi. All right, so let's go ahead and do this. And if I multiply anything by 1, it's really just not changing it. It's just changing the way it looks. So I've got to multiply. So in essence, what I'm doing is multiplying everything by an I. And so I have an I squared on that 12, and I have an I squared down there. All right, so what's that going to give me? That gives me a 9I plus 12 times negative ichi. Remember, that's what I squared is, times 3 times negative 1. So that gives me positive 9I minus 12 all over negative 3. Now, whenever we have one thing on the bottom, it's important to simplify. And you can share that with both of those. And we always want to do this if a 3 goes into both of those. And 3 does, right? 3 goes into 9 3 times. And what's interesting here is I get a negative 12 over a negative 3. 3 goes into 12 4 times. So this here gives me negative 3I, right? Because 9 divided by negative 3 is negative 3. And negative 12 divided by negative 3 is a 4. And then we said earlier, remember, on the SAT, they're always going to write the I second. That's technically how we write a complex number. In class, I will give you 100% for both of those. Okay, but that's how we divide complex numbers. Now, I'm going to do one more of those before we go on, all right? And then I probably won't have to do some of these other pages. But let's say we have 5 plus 2I over 4I. Let's say we have that. Now, once again, I just have one thing down here, but in math, SAT, we don't want any complex numbers in the denominator. So how do I get rid of that complex number? Well, I multiply the bottom by an I, a top by I. That's really just ichi. So it means I'm not really changing it. I'm just changing the way it looks. So then I give an I to everything, right? You're multiplying an I by everything. Okay, 4I squared. What's that give me? That gives me 5I plus 2 times negative 1, 4 times negative 1, which gives me a 5I minus 2 all over negative 4. Now, does a 4 have a factor that go into 5 and 2? No, it doesn't. So then that means we can leave the answer like that, right? Some people say 2/4 is 1/2, but you can only simplify something with the bottom if you can simplify all of it. And since 4 doesn't go into 5 or 5 doesn't go into 4, you can't do it. That is my final answer, okay? Now, obviously, it gets a little bit rougher if we have more than one thing down there, like this one. I got 2 things in the bottom, okay? 2 things in the bottom. How the heck? This is much more difficult, okay? Do not write this down. Don't write this down. But if I put an I there and an I there, I get 2I plus 3I squared, and I get 1I minus 4I squared. I'm still stuck with an I on the bottom. That's no good, okay? When dealing with complex numbers and ratios or fractions, you cannot have a negative, you cannot have an I in the bottom. So how the heck do I get rid of this I in this bottom? Well, if you have 2 things, you've got to multiply by a conjugate. What the heck is a conjugate, Mr. T? Well, watch what happens here. A conjugate means you write down the same exact thing that's on the bottom. Same exact thing that's on the bottom, but you just change the sign in the middle, minus, plus. And remember, it's got to be the same thing there, because then that means I'm really just multiplying it by a 1. And if I multiply it by a 1, it's really still the same thing. I'm just changing the way it looks. Now, there's a lot of work involved here, so let's get it. Okay? You have you got to share that 2 to both of those things, right? Which would give me a 2 plus 8i. That guy's donezo. Then you got to share that 3i to both of those things, and I get a 3i. So these are very involved problems, but they're so much fun because there's so much work all over. Now you share. Now I'm going to give you guys a shortcut. Okay, a shortcut. And we all like shortcuts, but you're only allowed to do shortcuts for conjugates. This guy here is a conjugate with this guy here. Why? Because they're the same exact thing, just the middle sign has changed. And whenever that is the case, you just have to multiply the first guy with the first guy, which is Ichi, and the last guy, which is negative 16i squared. Now, Mr. T, why do I have to do that? Well, if you multiply the whole thing out like you would, the middle dudes always cancel. These guys will cancel with the bottom one. That's why we use conjugates, because the i's cancel, and then we get the i's out of here. Get out of here. All right, right here, what do we get? We get 2 plus 11i plus 12 times negative 1. And in the bottom, I get 1 minus 16 times negative 1, which gives us 2 plus 11i minus 12 all over 1 plus 16, which gives me a final answer of negative 10 plus 11i over 17. Does a 17 go into 10 and 11? Do they have anything in common? No, so donezo. That's it. Man, that was a lot to take in, Mr. T. It sure was. So guess what? We're going to do one more. At least one more. All right, let's go ahead and do number 5, right? That's a piece of cake because there's only one thing down there. These things only get tougher when you have a binomial or 2 things in the bottom, right? And if I have 2 things on the bottom, the only way to get rid of the I is you multiply the top and the bottom by the conjugate. What's the conjugate? Now, some of you will continually make this mistake. Do I change the number of the 3? No, stays the same. Only thing you change is that sign in the middle. So negative, negative. And then we just distribute, share that 5 to everything. Right? If you don't share to everything, right? Mama told me to share growing up, right? So you got to share with everybody, right? Negative 6i plus 8i squared all over. Okay. Oh, sweet. The bottom are conjugates. Oh, that means I don't have to do all that work. Let's go shortcut. Now, if it's conjugates, we can do the shortcut, which is 3 times 3, which is 9. And the last guy times the last guy, which is negative 16i squared. So what do we get? We get 15. Combine those 2 guys, negative 26i. Ooh, I have an I squared. What's an I squared? That's a negative 1. 9 minus 16 times negative 1. So on the top, I get 15 minus 26i minus 8 all over 9 plus 16. Combine those guys, 7 minus 26i all over 25. Does a 25 have something that can go on with 7 and 26? No, so it's donezo. That's the last one we're doing. All right. If you are struggling with these guys, make sure you come in. Okay. Please come in for some help. You've got some practice problems there. Okay. But let's go ahead and go to our last piece of information. In chapter 4, we can call it a wrap. All right, and that is, what are these guys' solutions? Okay, well, if they're asking me for solutions, and that's a quadratic, I've got 2 options. Well, option 1 for a quadratic is I can't factor anything, so maybe I could X that bad boy. Whew, oh my gosh, that's 5 times 2. But one guy's got to be negative, right? So let's go ahead and make one of those guys negative. Oh man, that sure does look like it works out, doesn't it, class? Did I do that right? I sure did. So maybe you could do that one, right? Going fast. No, I can't. Mr. T, that does equal negative 3, but it equals negative 10. So nothing works. What do we do when nothing works, class? We quadratic this bad boy, right? So let's quadratic this formula. B equals negative 3. C equals 5. See, it took me a moment there. It looked like it worked out, but it did not. Don't make it work out unless this dude is legit good to go. So we go x equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you're saying it that fast right now also. Now, what do we do when we do the quadratic formula? We do the discriminant first, correct? What is b? b is negative 3 squared. Make sure that negative is on the inside, right? Because it says b squared minus 4 times a times c. So that'd be 9 minus 4 times 2 times 5, and then be 9 minus 8 times 5 is 9 minus 40, which is negative 31. And before we learned section 4a, we would just say no solutions, donezo. But now, since we're smarter and we're in algebra 2 and we're building stuff in that toolbox, kind of like LBJ, toolbox, all right, we can handle with this. Now, how do we handle this? Well, we go x equals the opposite of b. What's the opposite of a negative 3? It's a positive. Plus or minus the square root of negative 31 all over 2 times a. Whoa, Mr. T, I got a negative in a square root. Class, what do we do with a negative in a square root? Easy peasy, Japonesey, right? If we have a negative in a square root, we just bring that I out, right? Now, do you guys know what the square root of 31 is? I don't. So we just get to leave that bad boy like that. But remember, we have two answers. So let's represent this as two answers, all right? So that means x equals 3 plus I square root 31 over 4. Or x equals 3 minus I square root of 31 over 4. All over. It's got to be all over. So you got your two answers, all right? And that's how we handle quadratics that have imaginary solutions. Okay, class? Do you want to see one more? And one thing you guys have to work on in class is if one person wants to see one more, guess what? We are seeing one more. So I bet you somebody at home said, yo, Mr. T, I want to see one more. So let's do one more. All right, let's go. Let's find those solutions. 3x squared minus x plus 2 equals 0. Once again, hey, those are 3. 3 times 2 is 6. Ooh, that looks like it works for sure. That's a negative 3 and a 2. That gives me a negative 1, but it does not give me a positive 6. It doesn't work. Remember, if it doesn't work, we go ahead and we have to quadratic formula. That's why the quadratic formula is nice, because the quadratic formula always works. Now, remember, when we do the quadratic formula, that's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Just keep on saying that over and over again, and you will never forget it. Okay, so we always want to do the discriminant first, which is b squared minus 4ac. What's b? b is negative 1 minus 4 times a times c. And you know what? I probably should have said this ahead of time. And since I didn't, maybe you should do it now. Hit pause and see if we can get the same answer. Okay. Negative 1 squared is 1. That's a 4 right there. Sorry. Minus 4 times 3 times 2. That'd be 1 minus, that'd be 12 times 2. And that'd be 1 minus 24. That's negative 23. Oh, snap. That means no solution. So if I was to graph this bad boy, it'd be a parabola going up, but it would never, ever, ever touch that x-axis. All right, but there are still solutions. They're just complex solutions or imaginary solutions, which means there's going to be an I in it. So we go x equals the opposite of b. The opposite of a negative 1 is a positive 1, plus or minus the square root of our discriminant, which is negative 23, all over 2 times a. Okay. Ooh, snap, Mr. T. There's a negative in a square root. How do we get rid of that? Well, we just bring the I out front because it's really the square root of negative 1. Okay. Boom. And then square root of 23. Do you know what it is? I don't know what it is. And it can't break down, right? That can't tree down. It's just 23 times 1. So then, hey, we just have to write this as two answers. What are the two answers? The two answers are x equals 1 plus I square root 23 over 6. And that 6 can't break down anything. Or, remember, or is the important word. X equals 1 minus I square root of 23 all over 6. Done. So that's it. Alohas. Let's call it a wrap on chapter 4. Ace the test coming in. Come in for help if you need it, but let's get it.